This is section 11.7. Okay, in this section we're going to integrate, use algebraic fractions using the partial fractions method. So, we've integrated fractions before, and that was the situation where you could have brought the denominator to the top and used the power function, or it led to ln. So you had an example of f dash over f, and you had to integrate it, and it went to ln of f function. So in this case, though, if you can see very clearly, this is a very typical partial fraction questions, because the denominator is factorized and you are ready to split it. And the question will normally have part A, where they ask you to split it into partial fractions, so it's not something, it's unusual for you to have to think about it for yourself, but it's not something out of the question. They could still ask you to do it by yourself. So we're going to split it, though, into two partial fractions. So it's a over x plus 1 plus b over x minus 2. So then imagine multiplying through by the denominator. You will have x minus 5 is equal, so this one multiplying it by the denominator, x plus 1 will cancel, so you'll be left with x minus 2, and then b will be getting x plus 1. So remember, one way of thinking it is what this one has x plus 1 in the denominator, so you need to times it by x minus 2, and this one already has x minus 2, so you times it by x plus 1. And then we are going to find the values of a and b. We're going to make x equal to 2 to begin with, so 2 minus 5, which is minus 3, that will disappear, and over here you've got 3b, so b is equal to minus 1. Let's substitute x equals minus 1. So over here you've got minus 6. So this is going to be minus 3a. So a is equal to 2, because that will go to 0. So our integral becomes the integral of 2 over x plus 1. So I'm rewriting our integral in terms of these. Minus 1 for b, so minus 1 over x minus 2 dx. Okay, and this is a quick ln function. You've got the linear function in the bottom. So remember, in terms of ln, if you've got k over ax plus b, then it goes to k over a ln ax plus b. So you need to remember to divide by whatever x is multiplied by. Here it's multiplied by 1, so this will go to 2 ln of x plus 1, and this one will go to minus ln of x minus 2, and there's plus c. So you might be required to combine all of these terms into one ln. In that case, you need to let c equals to ln a, and then you're going to move that 2 as a power. So it's x plus 1 squared minus ln x minus 2 and plus ln a. So combining these, a will times by x plus 1, so you write it as a single log. So these two will be going in the numerator, so it's a times x plus 1 squared. And this one, since it's got negative here, it will go to the denominator. There you go. So that the plus c is already here. It's included within that a. That's just an alternative way of writing the answer. But you could have just combined the first two, which is also a possibility. In that case, you are going to put the 2 as the power, or like here, and you just put ln of x plus 1 squared over x minus 2 plus c. Or you could put everything in the modulus as well. Okay, so let's have a look at part B. They are quite lengthy, those questions, but they are normally, students feel happy and secure with these. you've got 8x squared minus 19x plus 1 over 2x plus 1 multiplied by x minus 2 squared. Okay, so the numerator is a quadratic, the denominator is a cubic, so it's not an improper fraction, so you can happily split it into partial fractions. Be careful with the repeated factor. So 8x squared minus 19x plus 1 over 2x plus 1 multiplied by x minus 2 squared will give us a over 2x plus 1, b over x minus 2, and c over x minus 2 squared. So remember, repeated factor, you need to account for both possibilities. Okay, so we're going to bring these to common denominator, or imagine multiplying through by this denominator. So 8x squared minus 19x plus 1 is going to be, well, a has got 2x plus 1, so you need to times it by the other thing, so x minus 2 squared. B has got x minus 2, so if you use 1x minus 2, you're multiplying it by 2x plus 1, and then 1 of x minus 2. And finally, C is already multiplied by x minus 2 squared, so you've got left with giving it 2x plus 1. Right, let's find different values, make x equals 2. So this is going to be, let's put 2 in, so it's 8 times 2 squared minus 38 plus 1, so that's minus 5. This one goes to 0, so will this, because it's got x minus 2, so it's just this one. If you put 2 into this, you have 5c, so c is equal to minus 1. Let's put x equals to minus a half. So you will have, change this one to minus 0.5 squared, and this one is going to be minus 19 times minus 0.5, and then we've got plus 1. Just delete all the others. Clearly not deleting it right. Well, let's just start again. Obviously, using ANS key is the best, actually, so let's just show you how to do it. There you go. Put minus 0.5 as ANS, and then do a ANS squared minus 19 ANS plus 1. That's the quickest way. 25 over 2. Okay, if you put minus a half into this one, that's going to be minus a half and minus 2, so 2.5 squared. Okay, so 2.5 squared, just to confirm, that's 25 over 4. A. If you put this into this one, that disappears, into this one, that disappears. So if you divide 25 over 2 by 25 over 4, A is going to be equal to 2. So finally, let's choose another value for x. Let's pick 0. So if I put 0 there, it will give me 1. This one will go to minus 2 squared, which is 4, so it's 4a. This one will go to 1 times minus 2, so it's minus 2b. And this one will go to 1c. Now we already know what a and c are, so it's 1 is equal to 4 times 2, which is 8, minus 2b, and then minus 1. So 2b is equal to 6, giving me b equals to 3. Okay, so the integral here becomes a is equal to 2, so it's 2 over 2x plus 1. B is 3, so it's 3 over x minus 2. And c is 1, x minus 2 all squared. So all this prep, we haven't even started integrating. Just double check the coefficients are correct. I'm looking at the wrong questions. This is example B. I've got it 2 minus 1 plus 3. Perfect. Let's integrate it. So the first one here, I'll put I over here. So the first one goes to 2 over 2 ln 2x plus 1. The second one goes to 3 ln x minus 2. And the third one here, we've got to bring it to the top and give it the power of minus 2. And we're going to add 1 to the power, divide by that power. So it will go to x minus 2 to the power of minus 1 divided by minus 1. So it's minus 1 over x minus 2. But there is a minus here, so it's going to be minus minus, which is a plus. Plus c. Let's just cancel these. You can combine these again. There's a plus here, so move the 3 as the power, and you will write it as a product. So it's going to be x minus 2 cubed times 2x plus 1. So I'll put 2x plus 1 first, and then x minus 2 cubed next. Like I said, they are quite lengthy, those questions. So the last question in this example, example 20, we're still on example 20, is, well, looks quite small. Let's have a look. Okay, so here we need to factorize the denominator. Let's just do that. Difference of 2 squares. Okay, so it's a over 1 minus x plus b over 1 plus x. So a needs to be times by 1 plus x, and b needs to be times by 1 minus x. We're going to substitute 1. So we get 2 is equal to 2a. A is 1. Let's substitute minus 1. 2 is going to be equal to 1, take away negative 1 is 2b. So b is equal to 1 as well. Yeah, that works fine. So we've got the integral is going to be the integral of 1 over 1 minus x plus 1 over 1 plus x dx. So they're both ln's. This one is going to be ln x over minus 1. And this one is going to be, not ln x, I do apologize. Ln of the denominator, 1 minus x over minus 1 plus ln 1 plus x. So that's minus ln of 1 minus x plus ln of 1 plus x plus c. Again, c can be written as ln a if you want to. You can combine everything then, but let's just combine these two first. So it's ln of 1 plus x over 1 minus x, and you can leave it as plus c, or if you add ln a, which means you can times this and express it as a single log. So it's a lots of 1 plus x over 1 minus x. Okay, moving on to example 21. This time we've got 9x squared minus 3x plus 2 over 9x squared minus 4. We've got to find the integral of that. Now this is improper fraction, so we need to divide. Okay, so we are going to squeeze out that denominator from the top. So it's got to be dividing by 9x squared over minus 4. So start filling in the grid with 9x squared, that's 1. 1 times minus 4 is minus 4. and the rest is going to be the remainder. So you've got 9x squared, we need to give it minus 3x, and altogether we want the numbers to add up to positive 2. So we've got minus 4 at the moment, so we need to add 6 to that, so everything adds up to our numerator. So our integral is going to be 1, and then the remainder, so it's plus minus 3x plus 6 over 9x squared minus 4. So over here we need to work on this, minus 3x plus 6. You could take the minus out, but I haven't, so I'll work with this one. So this is minus 3x plus 6 over 3x minus 2 times 3x plus 2. So this is going to be a over 3x minus 2 plus b over 3x plus 2. So comparing the numerators, so imagine this one, a needs to be times by 3x plus 2, and b needs to be multiplied by 3x minus 2. So subbing x equals minus 2/3, that will go to plus 2 and 6, which is 8. That will disappear. This here will give me minus 2 and minus 2, so minus 4b. b will be equal to minus 2. Sub 2/3. So if I put 2/3 into this, that will give me minus 2 plus 6, which is 4. And then 2/3 into this will give me 2 plus 2, which is 4a. So a is equal to 1. So altogether, my integral is going to be 1, and then plus this. So a is equal to 1, and b is equal to minus 2, so put minus 2 over 3x plus 2. And now integrating this. So 1 goes to x, this one goes to 1/3 of ln 3x minus 2, and this one goes to minus 2, because 2 on the top divided by 3, so 2/3 ln of 3x plus 2 plus c. And you may wish to combine. Okay, let's combine logs here. So you can just combine these two. I think it was actually x over here. I can't remember if it was plus or not. So it's x, let's say it was plus. Let's just check how to combine these two. So you can take 1/3 out, and then you've got ln 3x minus 2 minus, and 2 will be left from this fraction, 2 ln 3x plus 2. And then these two can be combined. As soon as you put the power as a squared, you have 1/3 over a one single log. The one that's positive, 3x minus 2, goes on the top, and the bottom was 3x plus 2 all squared. And you can either put modulus around the numerator or the whole thing. So do plus c. Now you could also convert plus c into logs, but because we then still are left with x, there is no point. Okay, so that's to help you with the end of that example 21.